Here two cells of having same e.m.f connected in stage to external resistance are cells having external resistance R1 R2 where R1 is more than R2. When the circuit is closed, potential difference across the first cell is zero. We have to find out the external resistance. We drawn this circuit here. In this cell, both the cells are supportive. Current here is in clockwise direction. Current I equal to total voltage E plus E divided by external resistance plus sum of internal resistance. When voltage across A and B is zero, so using the Kirchhoff voltage law, AB equal to drop E in the opposite direction from 1 to and the opposite direction current, that is rise I R1 is given the question VAB is 0. So here equal to I R1 and I will be upon capital R plus R1 plus R2 and R1. Here E cancel out, cross multiplication is to R1. So R will be R1 minus R2. Here option correct. In this question, 10 cells identical connected in series are needed to a wire of length 1 meter of radius r by 10 degrees Celsius. Now, how many cells n? You have to find n. How many cells are required to the wire of length 2 meter? Radius is same, temperature size is same, and time is also same. You have to find how many cells are required. It double length wire. This question, 10 cells, let us say 10 cells all are identical, ignoring the internal resistance. The length of this wire L of radius are same, material same, that the resistance of this wire is R. Then we have to heat this. Temperature rises 10 degrees Celsius, radius is same, time is also same. So here heat will be equal to m. M is the mass of this wire. As specific delta T, temperature rise is equal to P square, 10 Celsius, 10 E ka square upon R time. So here M as delta T equal to 100 T square upon R. First equation. Now, second part here is n cells. We are taking here identical. Number of cells are required here is n cells. and now length is double. The length here is double. So 12 length, mass is also double. As length is double, mass is also double. But temperature rise is same and time taken is also same. Now heat ms delta T 2m s into delta T. So now n square E square divided by resistance भी डबल हो जाएगा T. Now question 2 by question 1 get here ms delta T 100 E square upon R T T R squared R cancel out ms delta T cancel out. So here it will be 2 equal to n square upon 100. So here n square is 200 multiplied by 2 400. N will be 20. So 20 cells are required. Option 1 is correct. In this question, n cells are there, identical n cells are there, internal also same. They are connected in series. The terminals of the battery short circuited and current I is measured. They plotted the graph between current and number of cells. So here, let us say we have taken n cells, identical n cells. N cells are there and these are sorted. Current is I flowing. So what is I here? NE divided by NR and cancel out, so E upon R. Now I've plotted the graph between the current I or small I here versus N. I does not depend on N. So whatever number of N problem current constant I. So here option 1 is correct. Question 3. The first law is total current incoming equal to total current outgoing, or algebraic sum of current is 0. Depends on the conservation of charge. So option C is correct. The first law and second law based on conservation of charge and conservation of energy. First law based on conservation of charge, second law based on conservation of energy. So option 3 is correct. In this question, the two cells are like this connected and both are connected across the external wire. In the first cell, coming current, incoming I1 current, and here is I2 current. External resistance sum I1 plus I2 of current law. So in this circuit, we have to write the equation. Let us say we are writing the equation from the first point, the clockwise direction using Kirchhoff voltage law. It is rise, so E1 from 1 to point rise, and the direction of current drop. I1 plus I2 into R, and here it is I1. I1 to return to drop again. So I1 R1 is 0. Option 4 is here. Kirchhoff first law or junction law based on conservation of charge, and second law based on conservation of energy. It means both the A and B statements correct. So option 4 is correct here. Option 4 is correct. Question 8. This is a circuit given, and it is given at the point A, potential of point A. So we have to find the potential at B. So using Kirchhoff current law, here I1 is 1 ampere current from A to C. Then here, but this side 2 ampere means 2, but 1 ampere current flow from D to C. So 1 ampere, 1 ampere is 2 ampere. So current are satisfied. Now A, D, and here point B and volt. Here positive negative is 1 volt. And using the Kirchhoff voltage law, A to B, here VAB equal to A to C minus, so rise 1 volt, and C to D in the opposite direction of current IR, so it is positive 1 into 2 inch, and D to B drop, so 2. 2 and 2 cancel out, and it's 1 volt. So VAB 1 volt cancel here. So VAB will be minus A minus VB equal to 1. A is given 0, minus minus plus. VB is equal to plus 1. Choosing option 1 is correct. In this question, cell A and B positive negative. We have to find AB. R1 is given 500, R is dead. We have to find out B. We have drawn this circle like, and current in galvanometer is 0. It is only possible when EB equal to, now the left circuit current I will be total voltage equal across the resistance 500 plus 100 means 600. Here 6 cancel हो गया, 2 upon 100 means 1 by 50 current. And now AB equal to I R, R is 100. AB means 1 by 500 means 2 volt. So option